Vast Haven-1 Commercial Space Station Report. Date, January 29, 2025. Prepared by, your name. Subject, Overview of the Haven-1 Commercial Space Station. Introduction. The Haven-1 space station developed by VAST represents a significant milestone in the evolution of commercial space travel and habitation. Scheduled for launch no earlier than August 2025, this pioneering facility is designed to cater to a diverse array of missions, including those for private astronauts, government agencies, and scientific research organizations. With a habitable volume of 45 cubic meters and the capacity to accommodate 4 crew members for up to 30 days, Haven-1 aims to redefine access to space and bolster research and development in microgravity environments. Key features and specifications. Haven-1 is engineered with a multitude of innovative features that set it apart from previous space stations. Dimensions and capacity. Height, 10.1 meters. Diameter, 4.4 meters. Mass, 14,000 kilograms. Habitable volume, 45 cubic meters. Pressurized volume, 80 cubic meters. Power output, 200 W. Crew and missions. Accommodates up to 4 crew members. Missions can last up to 30 days. Designed for both government and private astronaut missions. Advanced technology. 1.1 meter domed window for panoramic views of Earth. Deployable communal table for crew interaction. Connectivity through SpaceX's Starlink system, ensuring high-speed internet access. Transportation. Will be launched using SpaceX's Falcon 9 rocket. Crew will travel to Haven-1 aboard the SpaceX Dragon spacecraft. Mission objectives. The Haven-1 space station aims to fulfill several key mission objectives. 1. Government and industry research. Facilitate research and development in microgravity for both U.S. and international astronauts. Provide a platform for local industries to partner in scientific endeavors. 2. Private astronaut missions. Offer individuals the opportunity to experience space while contributing to scientific knowledge. Engage in various activities that promote space exploration. 3. Payload missions. Conduct in-space manufacturing and research. Leveraging the station's advanced facilities and continuous data monitoring capabilities. Timeline of events. The journey leading to the development of Haven-1 can be traced through several pivotal milestones. Founding of VAST 2021, the company was established with a focus on creating affordable artificial gravity space stations. Announcement of Haven-1 May 2023, VAST unveiled its plans for the first commercial space station, marking a significant advancement in private space exploration. Launch preparations 2025, Haven-1 is set to launch aboard a SpaceX Falcon 9 rocket, initially operating independently before becoming part of a larger multi-module station developed by VAST. Partnership and future vision. VAST has formed a strategic partnership with SpaceX crucial for the success of Haven-1. This collaboration not only facilitates reliable transportation to and from the station but also underscores VAST's ambition to develop larger spinning artificial gravity space stations capable of supporting long-term human habitation beyond low Earth orbit. The partnership also includes options for additional crewed missions, further expanding the potential for research and exploration. Market and research opportunities. VAST aims to attract a diverse clientele for Haven-1 missions, including government agencies, providing a platform for scientists and researchers to conduct experiments in microgravity. Private individuals, offering unique opportunities for those interested in participating in space missions, whether for scientific or personal reasons. Commercial partnerships, engaging with industries looking to leverage microgravity for advanced manufacturing and research. The station is equipped to accommodate a variety of scientific experiments with provisions for up to 150 kilograms of preloaded cargo mass and 1000 W of power available for research purposes. Differences between sources. While all sources provide consistent information regarding Haven-1's launch date and key features, variations exist in their focus areas. Source 1 emphasizes technical specifications and the station's interior design, highlighting the innovative aspects of Haven-1. Source 2 places more emphasis on the commercial opportunities and mission types available, indicating a broader target audience for participation in space missions. Conclusion. The Haven-1 space station marks a transformative step towards the commercialization of space travel and habitation. With its advanced technology, strategic partnerships, and a clear vision for future expansion, VAST is positioned to lead a new era of exploration that merges scientific advancement with commercial opportunities. As humanity seeks to establish a more permanent presence in space, Haven-1 stands as a beacon of innovation, promising to enhance our understanding of microgravity and pave the way for future endeavors beyond Earth. For more information, please visit VAST website www.vastspace.com/haven1. References. 1. VAST official website, Haven-1, https://www.vastspace.com/haven1. 2. VAST updates, Haven-1 announcements, www.vastspace.com/updates/VAST announces the Haven-1 and VAST-1 human spaceflight mission launched by SpaceX on a Dragon spacecraft. 3. General information, VAST overviews, www.vastspace.com/. This report aims to provide a comprehensive overview of the Haven-1 commercial space station and its significance in the realm of space exploration and habitation. Counterintuitive information regarding the VAST Haven-1 commercial space station includes: 1. Commercial versus government focus. While one might expect a commercial space station primarily to cater to private astronauts and commercial ventures, Haven-1 is equally focused on government and industry missions. This dual purpose may seem counterintuitive in a landscape where commercial entities often prioritize profit-driven missions over governmental contracts. 2. Artificial gravity ambitions. The long-term vision of VAST includes developing spinning artificial gravity space stations, which could seem counterintuitive given that most current space stations operate in microgravity. The notion of creating artificial gravity in a commercial setting raises questions about the necessity and demand for such technology when existing stations are designed for microgravity research. 3. Integration into larger station. The plan for Haven-1 to initially operate independently before being integrated into a larger space station could be seen as a counterintuitive approach. Typically, one would expect a new station to be part of a larger network from the outset, rather than starting as a standalone unit with the intention of later integration. 4. Sales of individual seats. VAST's model of selling individual seats for missions may appear counterintuitive given the costs associated with space travel. The expectation might be that space travel would remain a primarily government-funded or corporate venture, yet VAST is actively marketing experiences to private individuals, suggesting a broader democratized access to space. 5. Partnership with SpaceX for training. The reliance on SpaceX for crew training, which includes emergency preparedness and spacecraft operations, might seem counterintuitive for a company developing its own space station. This reliance indicates a level of dependency on established aerospace firms that may not be anticipated from a nascent space habitation company. 6. Focus on research and manufacturing. The emphasis on in-space manufacturing and research capabilities on Haven-1 may seem counterintuitive when many view commercial space stations as primarily tourist destinations. This strategic focus on scientific endeavors positions Haven-1 not just as a luxury experience but as a pivotal player in advancing technology and knowledge in space. 7. Always-on internet via Starlink. the integration of high-speed internet via SpaceX's Starlink aboard a commercial space station could be seen as counterintuitive, as one might assume that a space station's primary function would revolve around scientific research rather than connectivity. However, this feature highlights the importance of constant communication and data transfer in modern space missions. 8. Affordable access to space. The narrative of creating affordable access to space through a commercial space station could seem counterintuitive given the high costs traditionally associated with space travel. VAST's approach to making space more accessible contrasts sharply with the historical exclusivity of space missions, challenging preconceived notions about who can participate in space exploration. 9. Environmental considerations. The design and operational plans for Haven-1, which include life support systems and consumables management, may seem counterintuitive when considering the environmental impact of space travel. While many industries are moving towards sustainability, the space industry often grapples with the ecological footprint of launches and operations in space. 10. Microgravity research for Earth benefits. The focus on conducting research in microgravity that benefits life on Earth may seem counterintuitive, as one could argue that the primary goal of commercial ventures is profit. However, VAST's commitment to scientific advancement demonstrates a blending of commercial interests with broader humanitarian objectives, challenging the notion that commercial space travel is solely about profit. These counterintuitive aspects of the Haven-1 project showcase the innovative strategies and perspectives that VAST is employing to shape the future of commercial space travel and habitation. Important overlooked aspects of the VAST Haven-1 commercial space station report. 1. Artificial gravity experiment. One of the most significant yet often overlooked aspects of Haven-1 is its potential involvement in artificial gravity experiments. VAST's long-term vision includes the development of spinning artificial gravity space stations. The Haven-1 station is expected to facilitate the first artificial gravity tests in a commercial setting, which could redefine long-duration human spaceflight by mitigating the adverse effects of microgravity on human health. This is crucial as current space missions are limited by the health risks associated with prolonged exposure to zero gravity, including muscle atrophy and bone density loss. 2. Economic implications. The implications for the commercial space economy are substantial. Haven-1 represents a shift towards a more privatized space exploration model where private individuals and organizations can conduct research, development, and even tourism in space. This could lead to a new era of innovation and investment in space technologies, stimulating advancements that may not occur in a traditional government-led environment. The ability for private astronauts to participate in missions could democratize access to space and inspire a new generation of entrepreneurs in the space sector. 3. Microgravity research and manufacturing. The report mentions that Haven-1 will serve as a platform for microgravity research and in-space manufacturing, but the significance of these activities can be overlooked. Microgravity environments have unique properties that can enhance materials science, pharmaceuticals, and biological research. The ability to develop and manufacture products in space could lead to breakthroughs that are impossible on Earth, such as producing purer materials or growing cells in ways that are not feasible in gravity. This could open up new markets and applications for space-based manufacturing. 4. Partnership with SpaceX. While the partnership with SpaceX is highlighted, the depth of this collaboration is often underestimated. SpaceX's expertise and established infrastructure in launching and managing crewed missions provide a level of reliability and safety that is critical for commercial space operations. The inclusion of Starlink connectivity for high-speed internet in space is also a significant advancement. This feature not only enhances the living experience for crew members but also allows for real-time data transfer and remote collaboration on experiments, which can significantly benefit scientific research. 5. Global collaboration and inclusion. The report notes the potential for international astronauts to participate in missions on Haven-1, yet the implications of this global collaboration are profound. It emphasizes a future where space exploration is not solely dominated by a few nations but is a collaborative endeavor involving multiple countries. This could foster international goodwill and cooperation, potentially leading to shared scientific advances and collective problem-solving for challenges such as climate change and resource scarcity on Earth. 6. Commercial tourism and public engagement. The prospect of commercial astronaut missions opens up space tourism to a broader audience. This could have significant implications for public interest in space exploration and science. The participation of private individuals in space missions can inspire future generations to pursue careers in STEM fields and increase public support for space programs. Moreover, the experience of individuals from diverse backgrounds in space can contribute to a richer narrative about humanity's journey into the cosmos, promoting a sense of shared experience and responsibility for our planet. 7. Sustainability and long-term habitation. The report mentions life support functions and consumables for the duration of missions but does not delve deeply into sustainability practices. As humanity looks to expand its presence in space, developing sustainable practices for life support and resource utilization will be critical. This includes recycling water and air and potentially growing food in space, which are vital for long-term habitation on future space stations or missions to Mars and beyond. 8. Infrastructure for future missions. While Haven-1 is described as a standalone commercial space station, its role as a precursor to a larger multi-module station is significant. This infrastructure is essential for future exploration missions beyond low Earth orbit, including lunar and Martian missions. The development of Haven-1 could serve as a testing ground for technologies and systems that will be critical for sustaining human life on longer missions, thus playing a pivotal role in humanity's broader exploration goals. 9. Psychological and social dynamics. The report does not address the psychological and social dynamics of living in a confined space like Haven-1 for extended periods. Understanding how crew members cope with isolation and maintain mental health is crucial for the success of long-duration missions. Insights gained from these missions could inform future designs of habitats in space and strategies for crew management, which will be essential as missions extend beyond the current capabilities and durations. In summary, while the vast Haven-1 report covers the technical specifications and mission objectives, the broader implications of this commercial space station extend far beyond immediate goals. The significance of artificial gravity research, economic opportunities in a privatized space sector, global collaboration, and the foundations for sustainable long-term habitation are critical elements that, if recognized and acted upon, could greatly enhance humanity's future in space exploration. 1. Innovative design and specifications of Haven-1. Haven-1 is poised to be a groundbreaking development in space habitation with its human-centric design featuring a 1.1-meter domed window for panoramic views, personal crew quarters, and a communal area. The station's specifications include a habitable volume of 45 cubic meters accommodating 4 crew members for missions lasting up to 30 days. Its deployment strategy utilizing SpaceX's Falcon 9 rocket and Dragon spacecraft ensures reliable transportation, marking a significant advancement in the commercial space industry. 2. Mission objectives and opportunities. Haven-1 aims to serve diverse mission objectives including government and industry research, private astronaut missions, and payload operations for in-space manufacturing. This multifaceted approach not only opens avenues for scientific inquiry in microgravity but also democratizes access to space exploration by allowing private individuals to participate in these missions, thus fostering a new era of public engagement in space science. 3. Strategic partnership with SpaceX. The collaboration between VAST and SpaceX is a cornerstone of Haven-1's development and operational success. SpaceX's proven launch capabilities and support for crew training solidify the reliability of Haven-1's missions. This partnership exemplifies the trend of leveraging established aerospace companies to facilitate the growth of commercial space ventures, highlighting a shift towards more privatized and collaborative models of space exploration. For future vision and expansion plans, Vast's long-term vision extends beyond the launch of Haven-1. The company aims to develop larger multi-module space stations capable of artificial gravity, thereby addressing the challenges of long-term human habitation in space. This ambition not only positions VAST as a key player in the future of space stations post-International Space Station ISS but also reflects a broader trend in the aerospace industry towards sustainable and long-duration space missions, paving the way for humanity's expansion into deeper space. 1. International Space Station ISS, a collaborative endeavor. The ISS is perhaps the most famous example of a multinational collaboration in space exploration. Launched in 1998, the ISS serves as a microgravity research laboratory where scientific research is conducted in astrobiology, astronomy, meteorology, and other fields. It is a joint project involving 5 space agencies: NASA United States, Roscosmos Russia, JAXA Japan, ESA Europe, and CSA Canada. The ISS has been continuously inhabited since November 2000 and has hosted astronauts from various countries, showcasing the potential of international cooperation in space. The ISS represents a significant step towards understanding long-duration human habitation in space, paving the way for future commercial ventures like the Haven-1 space station. 2. Mir Space Station, pioneering commercial use of space. The Mir space station, operated by the Soviet Union and later by Russia from 1986 to 2001, was one of the first modular space stations and an important precursor to the ISS. Mir was notable for its long-term manned missions, which provided invaluable data on the effects of living in space over extended periods. As commercial space endeavors began to emerge, Mir also allowed for private astronauts, including space tourists, to visit and conduct research. This transition towards commercial use of space set the stage for future developments in commercial space stations like Haven-1. 3. Skylab, the United States' first space station. Skylab was the first United States space station, launched by NASA in 1973. It operated until 1974 and hosted 3 crewed missions where astronauts conducted scientific experiments and observations of the Earth. Skylab was instrumental in demonstrating the feasibility of long-duration human spaceflight and conducting research in microgravity. The station faced challenges including damage during launch, which required innovative solutions for the crew to repair the station upon arrival. Skylab's legacy continues to influence the design and operation of future space stations, including the commercial aspirations of companies like VAST with Haven-1. Future outlook for VAST Haven-1 commercial space station. As we approach the anticipated launch of Haven-1 in August 2025, the implications of this pioneering commercial space station extend far beyond mere exploration. They signal a transformative era in space habitation and utilization. Here, we explore key predictions and potential developments surrounding Haven-1 and the broader landscape of commercial spaceflight over the next decade. 1. Expansion of commercial space tourism. Haven-1 is poised to catalyze the growth of commercial space tourism. With its design accommodating private astronauts, the station is expected to attract affluent individuals eager to experience microgravity and witness breathtaking views of Earth. As ticket sales for these missions gain momentum, we anticipate a burgeoning market for space tourism, with prices gradually decreasing as technology matures and competition increases. 2. Increased research and development opportunities. The station will serve as a microgravity laboratory, facilitating groundbreaking research in various fields including pharmaceuticals, materials science, and biological studies. As more private entities and research organizations recognize the value of microgravity, we predict a surge in research proposals and payload missions aboard Haven-1. This influx will enhance scientific collaboration and innovation, solidifying Haven-1's role as an indispensable asset in the scientific community. 3. Advancements in in-space manufacturing. Haven-1 will provide a platform for in-space manufacturing, allowing for the production of materials and goods that leverage the unique properties of microgravity. we expect to see initial experiments focusing on 3D printing and the production of high-value materials such as fiber optics and pharmaceuticals. As these technologies mature, they could lead to a new era of manufacturing capabilities, reducing the need for Earth-based production and potentially lowering costs for numerous industries. 4. Development of artificial gravity technologies. VAST's long-term vision includes the development of larger spinning artificial gravity stations. Initial experiments aboard Haven-1 could lay the groundwork for this ambitious goal. As research on artificial gravity progresses, there may be significant advancements in understanding its effects on human physiology, which is critical for long-duration space missions beyond low Earth orbit (LEO). 5. Collaborative international missions. Haven-1's role as a commercial hub may foster international collaboration in space exploration. Governments and agencies, particularly those transitioning from the International Space Station (ISS), could utilize Haven-1 for joint missions and research. This collaborative spirit could lead to shared technologies, resources, and expertise, further propelling humanity's exploration of space. 6. Integration into broader space infrastructure. Haven-1 is expected to serve as a precursor to a larger multi-module space station system. The integration of Haven-1 into this broader infrastructure will likely begin as early as the late 2020s. By establishing a network of commercial space stations, VAST could play a significant role in creating a sustainable presence in orbit, enabling more extensive scientific research and commercial activities. 7. Enhanced connectivity and communication. With SpaceX's Starlink providing high-speed internet access to Haven-1, we anticipate an enhancement in communication capabilities for both crew members and scientific operations. This connectivity will allow for real-time data transmission, remote collaboration, and improved operational efficiency, ultimately benefiting all stakeholders involved in missions aboard the station. 8. Regulatory evolution and industry standards. As commercial spaceflight becomes more prevalent, regulatory frameworks will need to adapt. We predict that agencies like NASA and the FAA will work closely with private companies to establish safety protocols and operational standards. This evolution will ensure that commercial missions are conducted safely while fostering an environment conducive to innovation. 9. Public engagement and education. The launch of Haven-1 will likely inspire renewed interest in space among the general public. Educational programs and outreach initiatives could emerge aimed at engaging students and young professionals in STEM fields. By showcasing the potential of commercial space stations, VAST can help cultivate the next generation of scientists, engineers, and explorers. 10. Sustainable practices in space operations. As the industry matures, there is growing awareness of the need for sustainable practices in space operations. We predict that Haven-1 will implement eco-friendly technologies such as advanced waste management and energy-efficient systems, setting a precedent for future space stations. This commitment to sustainability will be crucial as humanity expands its footprint in space. Conclusion. Haven-1 represents a significant milestone not only for VAST but for the future of commercial space exploration and habitation. As it prepares for launch, the station is expected to usher in a new era characterized by increased accessibility, collaborative research, and advancements in technology. The next decade promises to be a thrilling period of innovation and discovery, with Haven-1 at the forefront of humanity's journey into the cosmos.